In a world that walks the line, there's a rare few who think outside the box together for the crew. To break the equations, not down to any rule. Exposing to the world the universe's own view. It takes the talent of the craftsman, it takes the mind of the fool, to make the vision realize energy and matter in a duel. To a break, to a duel. The old man Bills was running through his head. Cheryl probably got it hiding under his bed. Penny up the ante, making power for days. Don't listen to a word that the straight dope says. Might building batteries that power a ship. Victor comes and talking math, that's the water spiral dip. Sean chucking plasma volts a mile long. Sheila on the video making tone chucking prongs. Bernie breaking matter, they said it couldn't be done. And to all the people in the chat, I know you're having fun. So it's time to spend your Saturday with the dope and old man Bills.
Hello everybody, welcome. My name is Nathan. I was always know old man Bills. Guys, I got a freaking bee in my garage. What's up, Joe?
Going on, everybody? Little different view today. Doing something a little different. It's going to be a tip show. You're here for it.
Right on, brother. Right on. All right. I put this bee out later. Okay, we're talking about EM drives and what they're trying to do there, and they're trying to use the Lorentz force in order to create propulsion, basically in a tube, I guess you would say. The best way to look at this is if you took plasma in a tube and then you put a magnetic field on it on both sides and just coupled it like this. That's what they're doing. They're basically pinching plasma on both sides of it, more or less. You know what I mean? That's what they're trying to do. One of the main problems with trying to do that is you have a finite amount of energy going through it, and you can't couple any more energy to the air that's in the environment. They learned this on, what was it? The plasma channel, when he created his thruster and he couldn't get the amounts up high enough to go anywhere. It's because there's only a finite amount of air that you're messing with in that environment. So if you don't compress it in some way, and I don't just mean compress the one, you have to compress it and change the turbulence in it in order to get the thing to go further. So basically, you're not storing the pot. You're not creating enough momentum. You got to remember, jet plane takes fuel, takes the air, compresses it, puts it in a turbine. It creates pressure zones inside of it. Those pressure zones are what gives it the ability to add more and more and more to it. There's no pressure zone in the EM drive, just so you know. It's basically two magnetic coils that pinch. And if you're trying to create something in the center, that works out, but it doesn't work out if you're trying to create propulsion out of it. So what you're going to have to do is something that NASA did in their rocket engine. They tried an experimental rocket engine. They took the propellant and they made it swirl. So when you do a swirl in it, what are you doing? You're creating banking. When you create banking of energy inside there, you create vortexes inside the banking, which gives it a natural nozzle to go down and flow through, which means it creates more pressure inside and pushes more out, right? That's what's missing in this whole device. What do you think, Joe?
Well, first of all, like you said, the Lorentz force that it can be generated it's very, very light, because unfortunately, surface area that the charge is able to reach out and grab in order to redirect is very low. And I agree with you 100%. It's a compression issue. This is the reason that aircraft use a propeller, which has to speed. It uses different dynamics. Okay, in order to create the high and low pressure zones, to create the movement of the air, to create those high and pressure zones at high enough density levels that could occur. Unfortunately, the saturation levels that are inducing the Lorentz forces here, in order to extend them out in such a manner to have that type of volume, it becomes a diminishing return very, very, very quickly. And of course, there are tricks that, like you had mentioned, like NASA is trying, in order to, boost these types of numbers, and introducing laminar flow and through introducing vortice, stable vortex makes a lot of sense. But then again, you got to remember something. All this is doing at that point is a worse version of what already exists. And this is the mind frame that these areas of science seem to be stuck in. And the funny thing is that, in my opinion at least, and like I think I'm going to show you very shortly, they're not far off, but they're thinking about it the same old way. And the way is to exert, thrust from whatever you're trying to move to push your environment. Okay. And I think that they have it backwards. And that's where the, idea here is going to come from. Because what if it was your environment that thrusted you, not you thrusting against your environment? By putting the shoe on the other foot, it starts to make a lot more sense. It also becomes a lot more attainable. And that's sort of what I think about that. I mean, it's good science what they're doing, but the result is exactly as you would expect. And it's for the same exact reason that ramjets and scramjets, need to be going at Mach 3 or something like that, or Mach 2 and 2.5 before those sequences can be initiated. Because in order to have the highest amount of thrust, you need to get rid of the moving components, because that becomes the bottleneck at that point. But you need the moving components in order to get to the rate to be able to have self-induced thrust occur. And if you notice, in these transitional experimental engines, as they want to put it, it's still using traditional thrust. Okay, it goes from a regular standard jet, to a ramjet configuration where the blades move out of the way, but it keeps the center geometries to keep the laminar airflow, through that. It's the same as a Peregrine Falcon, and how it dives at 200 plus miles an hour. So in order for it to be able to breathe during a dive, it has to have a conical dimple in the middle. It's to get rid of the turbulence from the high pressure during the dive, right? So they need to be able to keep that configuration while doing away with the blades, in order to enter into a ramjet mode. But once that's established and then it reaches that next threshold, the trick is to then get rid of the cone, because then the cone becomes the bottleneck. The cone is choking the flow. But these geometric flows are so established that you could get rid of the cone at that point and have much more volume coming in, allowing for even greater thrust, right? Once you're able to then do away with the cone. So they needed to come up with a motor that's able to transition through these phases. And that's what they're trying to do with the rocket situation, is they're just trying to create the laminar environment, through spin. And then once they have it, removing as much restriction as possible for free flow that allows for basically, a ton more acceleration to still occur. It's self-amplifying. It's not putting more fuel through itself. It's just self-amplifying at that point.
Yeah, but the cone creates the spin on it. I think the spin is very important. They keep it there. I don't think you need to get rid of that pinch at all. It needs to stay in the system, because it's, when you see the exhaust come out, it's thin and then big and then thin. You know what I mean? In the perfect way that the thing's set up. So it's creating resonant pockets. You know what I mean? Just like that as a spin.
It's doing that because it's its combustion events and stuff are happening so rapidly, and it's moving so fast that it isn't, even though it appears in a constant state of compression and combustion, it's actually in an alternating cyclical state, in order to keep that laminar flow going. So that means that there's a secondary mechanism that's occurring, keep the spin, which is a three-dimensional helical spin, okay, for intents and purposes. But it needs to introduce another axis of dimensionality in order for the puff, puff, puff to occur at the highest levels of efficiency. That's because there has to be, eddy currents then that are secondary to that flow, okay, that work with each other and keep that level of compression. Once you have that, those eddy currents and the extra vector, again, that's going to create a cavitative type of appearance, because it needs to be in a state of compression decompression.
So what you said earlier about the level of speed you need before you get to that speaks directly to the pressure missing in EM drives. So
exactly,
they're not getting enough pressure in the inlet in order to create enough gases. So if you're going to create O3, you need enough O2 in there to basically feed it, right? Because you're basically combining an extra oxygen atom to it. So you need to remember that, and they're not getting enough pressure into the pipe. And that's what I mean by they're only pinching it, and the pinching it is doing a little bit, but there's not enough pressure originally in order to do it. So you have to take it and put it into a zone where you can spin the pressure up and create that vortex to push it through. That's what they're missing.
Right. So the funny thing is that those EM drives in any configuration, okay, they're going to repel faster and more efficiently than they're going to be able to charge the air, the environment.
Mm-hmm.
Period. So the funny thing is that the way to exploit that is what I think we would commonly consider to be antigravitic. Because once you put the shoe on the other foot, like I said earlier, and you stop depending on taking environment in at a specific rate, at a high, you need to be able to take the environment in at a rate that keeps up with the repulsion in order for the efficiency to be there. Okay,
and it means you need an ionization chamber.
Right. So
what ends up happening,
right. So you only have a very finite amount of ionization. Okay, and then when it goes into the repel state to create the thrust, it's excellent at repelling all of the ionized air. It's so excellent at it, okay, that it doesn't have enough ionized air to put through for it to be worth a damn. Okay, and whenever you want, and we could do it in a little bit and continue along this line of discussion, this is going to make a lot more sense to the audience because I'm going to draw you out what this solution is.
Gotcha. I just want to go over what the EM drives are doing and what they're missing before we get onto the right answer here, because they popularize them like it's the next coming, you know what I mean? And they're missing parts in it when they first start that runs them into failure. And I've seen it consistently throughout all the AM drives or any kind of propulsion system in that way. They're not understanding the fundamental nature of the gas that they're working with. And they say, no, we got it because we can compress it a little bit. Oh, it's like creating toroids. You can compress it, but if you didn't create the right flow to get it right, so if you didn't start with a pan feature like this and then compress it into a toroid, you'll never get the propulsion out of it. It's kind of the same concept. You have to realize what you're in before you can make it work for you. All right, Joe, give it to us. What do we need to do instead of doing this to get it right?
Okay, well, since we are talking about propulsion after all, I think that most of you have already heard me bring up the fact that, in my opinion at least, airplanes, okay, are anti-gravitic. Okay. Airplanes are anti-gravitic. We don't see it that way because of an airplane's need for forward motion. Okay, and use that additional inertial force. Okay, as a multiplier to the differentials that are required in order for lift to occur. All right, and that's something that I want to quickly demonstrate. I'm going to flip my camera around real quick as to how I came up with some of this stuff. So, sorry, it'll take me a sec. All right. Cool. All right. So, in an airplane, you have a propeller. Let's call it a prop plane, okay? And that prop is going to spin like that, all right? And by virtue of that rotational vector, the air going through it, okay, is going to be negative and positive. And from there, you're going to have a wing, more or less. Sorry, pretty crappy wing. All right. Now, this positive airflow is going to hit a wall. Okay. And it's actually going to go like this, boop, outward. And because the velocity is there, okay, there's going to be a lot of redirection once it goes outward. And that redirection is going to be over the wing and under the wing. Okay. And now people will say that the lift is going to occur mostly because they meet again. Whoa, they meet again. Yeah, well, that is just a simple way of thinking about it. It's nice that that happens. It's efficient that that happens, but that's not the reason. The reason is because you took your positive and you put a positive pressure down here and a negative pressure up here at a high differential. Now, there's other things that the shape of a wing does, okay, to exploit this differential further. Because as I said, there's forward motion that's required in order to get these differentials high enough. So they'll play with wings angle of attack. Okay, and what that's going to mean is that here's your wing, and if you bring the wing down a certain pitch, certain angle, okay, that's going to create an impact point, increasing the pressure even further on the bottom of the wing, separating that differential exponentially. And obviously that is going to create pressure that's going to push up and away, right? So equal and opposite reaction, up and away, and that means up. So that's how you're going to get your lift. Now, from the wing two, there's going to be vortices that occur. All right. And that's going to keep this airflow stable. So you end up with like a slipstream. And that's pretty much what makes something that weighs like, I don't know how many dozens of tons, but that's what makes that fly through the air, at, a pretty high speed, but still relatively low in the grand scheme of things, I'd have to say. So the next part of this was, how do you recreate this electromagnetically? Well, again, we're dealing with all this is energy, right? So you have an energy potential in the form of wind, coming through, and that's the energy source here. But that directly is an analogy just for any kind of energy. So if we look, and we start with a magnetic state, okay, and then we add a current state, right? And when it hits the wall, you add resistance, right? You could split it off. All right. And when you split it off, you're going to end up with another positive and negative, right? So that's pretty much what you're going to end up doing. So you start to realize quickly that you have a current state, a magnetic state, a scalar state, and then another current state that has a separate polarity despite only the positive coming in. Okay, so when you start to rearrange this, and then you realize the forces that you're trying to generate from an engineering standpoint, it starts to become very interesting very fast. And I'll flip over my piece of paper to see if I can show you what I mean. All right, so we're going to take the exact same energy vectoring now, and we're going to try to have everything work in the most efficient way possible. And we're going to try to do away with the fact that we have this limited amount of environment to pull in to achieve our means. And how we're going to do that is we're going to take Nathan's, of all things, because as if he isn't onto these things in the first place, right? Tesla coil, the way that he standard has it configured with a polarity bias at the bottom. All right, so we're going to look at it like this. Here's your primary coil. All right, and then little guys in there. This is your secondary coil going the same direction. All right, so you get the idea. Sorry, I'm behind the camera and I'm very far away. So there we go. So you get the idea. So now you have this magnetism component and this voltage differential that is, you know, increasing as it approaches the bottom. Okay, here you have a higher energy density. And here you have a higher potential, and I'll show you why. Because what you're going to do is you're going to take an aluminum plate and put it there. And then you're going to take an aluminum body and put it there. And another aluminum body and put it there. And you're going to have the top where the primary is separate from the rest of the secondary. All right. So what this is again, this is lower frequency, lower voltage, higher energy density. Because it's in, it's going to be putting out radiantly into this environment and surrounded by dielectric, you're going to end up with rotational eddy currents, all right, in there. And the same thing with the bottom, you know, and it's going to go sort of the, you know, other sort of way. And that's half of the equation. This is actually the easy part, you know, because realistically, we haven't dealt with like the Lorentz force all that much yet, but we're about to. So if you were to take a ceramic disc and you place it at the same line that your aluminum plate is at, and you were to place it in the core of the Tesla coil at that same level, and then you were to suspend a wire in the middle, and you have just a simple anode hooked up to that wire just above that center ceramic plate. And then the wire at the top exits that shell and connects to that outer shell. Then you were to do the same at the bottom where you have a plate hooked to the wire, metal plate, and you put that at the bottom of your ceramic. You suspend the wire down, exits the shell, hooks up to the bottom of the shell. Now, if you were to separate these two plates on the inside and outside with a thin insulator, and then you were to power this on, what are we going to end up seeing? Well, You power it on, and the inside, the inside of this, but the outside of the Tesla coil, this is the first thing that's going to start up. You're going to start to get high saturation levels in here, and you're going to start to get a lot of eddy currents through the induction in the presence of the geometric shell, which is dielectric. You're going to start to get your charging in the middle, okay, from the middle energies, okay, and this is going to go up path the least resistance, and it's going to start accumulating as like static potential, DC static potential, okay, on the outside of the shell. Now, as that saturation level starts to grow and grow, it's going to start to realize through this thin insulator after a point that the other one is there. And well, they're going to have a high resistance exchange, right? So they're going to exchange it at a very reduced rate, but just enough. Now, once that starts to grow, because that's reduced, the energy density of this static, okay, is going to start is putting out more than this exchange. So it continues to build. And in the meantime, these two in the middle start to realize that they are there. Now, because this is in a very focused stream, small area focused stream, and because this is a large area surrounding the entire craft, okay, you end up with a situation where there's a DC bias of this static. Okay, but there's an exchange on both sides, okay, that's happening in conjunction with one another. So that would create AC slosh. Okay, that would be the finishing of this circuit in a restricted way, AC slosh. Now, over time, once the density builds, there would be a RAV that forms right there because of the higher density, right in the middle of the Tesla coil. Well, anytime you spin plasma, okay, with a coil around it, you're going to then have reverse induction, amplifying the whole entire system. Now, why is this significant? Well, because this has a positive charge bias. This has a negative charge bias. This is in a state of great diffusion, but it's very, very dense just off the surface of that dielectric because there is a magnetic field overall, despite the eddy currents within that are separate, keeping the polarity biases bifurcated. They together are still connected through the coil itself, creating the overall magnetic field and compression. So there's a dense layer of this static potential just off the dielectric surface. Now, what ends up happening is as it goes out to a diffuse state, it ends up still charging the environment, okay? And it will bring this energy in from the environment. But then once it reaches the higher density part of this, it realizes that it is plus and it is plus and it is minus and it is minus, and it does what it does best and it goes away. So it sucks it in and blows it away while charging the entirety and separated by high density level. Now, whenever you have these conditions, you just did something. You've removed yourself from your environment because your environment is being drawn in and then pushed away. It's being drawn in, but then being pushed away. Well, what did we just say about why the EM drives suck? Because it's terrible at drawing it in fast enough. It could draw it in as fast as it can, meaning that the entire immediate environment would be consumed and it'll immediately repel it away. So it's easy to reach the numbers then where your environment becomes disassociated from your bubble that you created. And because you have internal, convection and an external magnetic field, now all of a sudden you are of your own environment, meaning that the environment is actually slipstreaming around you. Now, what happens when you do something simple, okay, like add a little resistance to a certain part of the system or shift the center of gravity of the system? Well, it creates an asymmetry in the field that's interacting with the environment. And that asymmetry, okay, creates a greater pressure on one spot. That asymmetry is enough to cause propulsion. But now, because you're pushing the environment away from you, well, there's nothing actually to slow you down or stop you. Cool. So that's how that works. There's a lot of scribble. I'm going to flip my camera around now.
I love all the pictures, Joe.
Yeah, man. I don't know. It's so what I found interesting is that by just taking everything that we've learned all along and combining that knowledge, taking what we already know works, and taking the deficiencies of other people's ideas and realizing that the deficiency is only a deficiency if that's what you're trying to use for that purpose. But if you just put the shoe on the other foot, well, all of a sudden, it's not a disadvantage. Now it's an exploitive advantage. So you don't try to push you don't try to push what it is you're trying to propel. You literally use the environment to cause the conditions to propel it for you. And the analogy of this would be like if you've ever had a bean in a pod. Well, right, the bean's in the pod, but then when you press the bean at the back, it shoots out of the pod. And that's sort of the idea.
Okay, give me 1 second, Joe. I'm trying to pull something up here for you. Basically, I wanted to show if I can find it. And I probably won't be able to. It's on my other computer. Because we could show the movement in the one Sean sent us.
Mm-hmm.
So I'm looking for that right now. I don't see it in my shorts area. I hate these different computers. There it is. Okay. So I wanted to show this so everybody can understand it. You see the voltage spiking over twice. When he gets to the third one, you'll notice the environment changes. Starting to pull in the gas from the environment. He hit it again and almost pulled it. This time no spark. Look what it does to the environmental gas. It just swirls. See, this is the kind of thing that you're creating on the inside. But if you spark over and discharge, it goes away. You know what I mean? But if you leave it alone, then it starts to mess with the air all around it. That's the gas that you're playing with. You're charging it. You're tapping, and then boom, you charge it, and immediately you get what you want. So I wanted to say this also, just so we understand what Alexei was trying to do in the gravity flyer. as Joe says, it creates the RAV, right? And we're doing the clay in the center, and we're putting anode and cathode at the top in order to get it done. Alexei was using the rotating plates as the anode and cathode in the situation, just like the RAV does.
Mhm.
And it was creating that environment. So it'd go bouncing back and forth between the two, and it would start to create that pressurized environment inside of it. Okay. It's kind of the same concept that Tesla coils still use to create the field on the outside. I would say that I prefer a spherical Tesla coil and the RAV on the inside to the flat plate design, but that's a matter of opinion. You know what I mean? I think either way it would be worth trying, to be honest with you. But I understand the flows inside, because it's not just changing the gas inside, it's changing the heat level of the gas inside.
Mhm.
And then you're creating the pressure zone around it with the fields that you create with that Tesla coil. And it's because it's a Slayer exciter, it tries to resonate with everything in its environment. So it's trying to take the frequency that's on the plate, or would be in the RAV in Joe's case, and it's trying to match that. So what it does is it creates a gradient between the two. So now you're getting zoning going up in frequency as you go out, and that zoning is based on the density of everything. So whatever gas there is would fall in that particular zone of density. Then it'd go to the next one, and then the next one, and before you know it, you have a shell that's created out of the gases themselves, which allows you to be decoupled from the environment.
Exactly. And there's more than one way to go about this. And
Mhm.
that is the point. Um, and the geometry of the Tesla coil too, like Nathan was saying, can that definitely be a significant factor. The key to it really is that it's all about it's the same as the RAV. It's all about separation of differentials. So you have a situation where in the inside again, it's going to be it's going to be a lower voltage, but it's going to be a higher amperage. Okay, and it's going to be in a more high density energy state at the top, whereas on the bottom, much higher voltage, lower amperage, much higher frequency in a more diffuse energy state. And then when you move to the core, this is where you're going to draw your high density equilibrium, because what you got to realize is it's creating an overall environment, okay, of non-equilibrium. Okay, so the top and the bottom are in a non-equilibrium state. The inside and outside are in a non-equilibrium state. The core, okay, and the rim are actually acting as the bridge of the non-equilibrium state where the exchanges take place. Because like anything, you see, if you don't have a semblance of a circuit, okay, the whole thing falls apart. So you can't have the outside fields, and have the inside fields and the outside fields grow if it doesn't loop back onto itself. Now, that doesn't mean that it necessarily powers itself, definitely not initially. But what it does mean is that it needs to be able to have that completion of the circuit, so the vector states could exist. You need, the Tesla coil itself only puts off radiant energy and with a magnetic component. And the eddy currents only reinforce that. So in order for you to get current and AC DC, working in conjunction with one another, you need to have that exchange that completes the circuit. And the RAV in the middle, okay, as we know, the RAV breathes, it pulses, right? It's
Mhm.
cavitative like that, expands and contracts. Well, the odd thing is that the discharge not discharge, the energy exchange between the anode and cathode within the core of the coil, being the RAV, okay, is at a much higher density level, okay, but it's equal to that is around the rim. And the only difference is that what's around the rim is a much larger surface area, so the density is different. So you have one flashing this way while the other's like that, and then you have one flashing this way when the other's like that, creating that additional frequency. And of course, because it's made of the center energy of the outer fields, it's all in resonance, but it's all in variable resonance with different frequencies because of the conditions being asymmetric. So, when you have the smaller areas at the higher frequencies, you're going to have the higher frequency levels. You're going to have lower frequencies where there's more surface area and more diffusion. And it really is going to exponentially feed the system as far as putting more energy into the system. But, well, that might lead to material failure. Yeah, maybe, but probably not, because the whole entire thing is that once it kicks up the highest of high energy levels, it's going to go path of least resistance. And because it's forming a static bias with, a loose plasma, more or less, surrounding the entire thing, that's going to be the least resistance path that it could take, which means that it's just going to look for more environment to ionize. And the environment is going to act as a heat sink of the whole thing from it failing, because it's just going to take the environment in, charging it faster and doing the pull in, push away faster, meaning that it could self-regulate. And, unlike most other systems that are sensitive, once this thing's going, all the pieces of it work like a serpentine belt on an engine, where if the engine is turning one wheel, it needs to turn the belt and the rest of the wheels in order for that one wheel to turn. It can't just turn the one wheel, right? So if something starts to give a little bit over here, something else just works a little bit harder to pull it right back into place. So the variables, the environmental variables that people say are sensitive to these types of EM structures, and setups, become far less significant. And once you do away with atmosphere, okay, this still works, and it works because it's still creating perturbatory excitation of the vacuum, and because it's able to do that, and it itself is the matter that's in the area. Okay, it's able to take the manifest energy of the vacuum of space and do the same exact thing with that energy. So the energy levels become even higher. So once it's up and going, it doesn't even depend on an environment or an atmosphere in order to have the same exact attributes. And that's because it's utilizing upper dimensional geometries and flows in order to have this occur in the first place.
So I just want to answer this question real quick, Joe. The counter-rotating disc must be wired with the counter-rotation windings of the Tesla coil. Basically, anytime you take a Tesla coil and make it bipolar, you're going to have opposite windings on each side. Think about it. If we're going in one direction, it'll come out to the right on the bottom, or see me going to the left, then it comes out going to the right on the top, even though it's the same exact winding. It's going to be counter rotation in the value that you put it in. So no matter where it sits in the primary, it's going to do that as soon as you go bipolar on it. So that was one thing I wanted to say. There was something else that goes on in this. I forgot. Sorry. Yeah, basically, I'll be honest with you. I think in the RAVs, I'd probably prefer a double RAV than a single. and it's on the clay, go one on each side of the clay. And there's a reason. There's a pulse that would bring out an equilibrium state, and only the coil itself, being up or down, would give it the vector it needs to move the energy up or down. But that sets you in a state where you don't have control of it. In order to get control of something like this, you would have to be able to move the secondary coil up and down at will. In order to get it and hammer it down as propulsion. And I say that, oh, this is what it was. I'm going to make the donut people happy real quick, okay? And explain something to you so you understand it. When we look at how atoms explode, okay, in nuclear devices, and you see what looks like a donut appear, okay, just understand something about the environment it just did to itself. It took something, spun it, brought it back around, and threw it through the center and created a cone. As soon as it created the cone, it created propulsion. That's what you're looking for. So we're looking at the center disk. It's making an I shape, okay, as the energy fields come off of it like this, right? What do you got to do? You have to take that piezo disc and push down on it and create the donut structure in order to create the propulsion. That's what you're doing. It's the only way that it does this in order to create the propulsion, because it gives it a vector direction to go to based on how the piezo itself pushes down and interacts with the fields. It's directly interacting with the Tesla coil field. You know it because that's the way you set it. You set the Tesla coil by where you hear it bounce back off of that field itself. That's why you're adjusting the Tesla coil more or less energy. But then what happens? You push it and boom, it shoots down in the center, and it takes the I shape and creates donut shape and creates the propulsion, which gives you the cone at the bottom, which forces it through. That's what's really going on here. So donut people be happy. Nathan finally used a donut in his explanation of something, but it's because of how it shapes the field. It didn't originally start that way.
Yeah, I mean, and the double wrap situation may actually just natively build without, just in the configuration that I described. I don't know that it necessarily has to be enticed. It might just ultimately come to be that way, depending on what the variable levels of energy are. I don't know particularly because okay, so because of the separation of differentials, my mind automatically goes to, if you have something on the inside high density like that you still need something on the outside that acts as the bleed.
Oh, and you do.
Right, you need something that connects the top and the bottom, or else there's no circuit, and then there's nothing to push and pull. So, again, that's where the small insulator in between top and bottom come in, is just to keep that kind of under control. And whatever the thickness or type of insulator it is probably going to be highly dependent on what the energy levels look like, because there might have to be a little bit of spacing or material work and experimentation to make sure that the exchange is one controls the other. So you want to maximize the exchange without having it connect to your circuit. If it arcs over and it has a pure circuit, it no longer functions. And again, that's how RAV forms. See, the anode arc, it never makes it in its arc form to the cathode, but maintains the relationship by pulling the energy, through to it, not arcing over. So, that's sort of the caveat to it. And like we had discussed when you and I had talked about this, having this, provided that this works, what it's doing is it's creating a ground state, and it's allowing for that recycling of energy and that completion of the circuit separate of its environment, which again is key to breaking locality. The long term at least. So it's something important to realize, because what you do in that core to loop it back around and connect it directly correlates to what the outside is doing too of that coil. And it was for that reason alone that I suggested, rather than PVC or something like that, that the tube probably needs to be made of a more robust insulated material like ceramic or something along those lines.
Gotcha.
For the Tesla coil.
Yeah. Well, I'd like to make it one out of ceramic, just if I can get it smooth enough on the outside. That'd be neat. By the way, I just want to say in the comments out there, I'm sorry if I deleted your comment and it was good. There's some Green Lantern dude who popped in and he's a real POS. So I was trying to get rid of his comment. So sorry about that, guys. All right. So yeah, I mean, I think with these EM drives, they're trying to do it for space, right? So they say there's not air in space and there's no water in space and there's nothing in space. They just seem to think it's empty. So that's what they're building it for, that environment. I think personally, that's probably the wrong way to go. You know what I mean? I don't think that that type of drive is good for space. You know what I mean? Because basically you need brakes in space is what you need. Getting yourself going doesn't seem that difficult. It's keeping, you know what I mean? Keeping the steady speed and then stopping at some point, because they get these things flying out there already with the simple drives that they have using simple gas in order to propel them. I mean, what is it? Voyager 1 already hit the edge of the solar system already. I mean, we're going to Mars. We're not, you know what I mean? We're not going to Pluto. It's not really something that essential. The bigger thing is you got brakes to stop when we get there. I mean, I know they use the planet itself, you know what I mean, the gravity and all that, yada yada. I'm just saying, I don't know that we need to reinvent the wheel to figure this one out. Inside the environment of Earth, though, yeah, you're going to have to change how you think about it entirely, because we got the wrong thinking. We think it's wide open pastures and nothing, and we're an environment of nothing. We just pressurize for no reason. Well, we're adding removing gas in order to pressurize. I mean, for God's sakes, let's use what's to our advantage around us. That's why when Joe talked about the environmental condition and changing it, well, it'd be no different than throwing a hollow ball inside of a running river. I mean, it's separate from its environment. It's it floats on top, goes in there, hits the vortices, pulls down. Subject to the flows of it. So we're subject to the flows of the gas environment we're in, which makes it simpler to understand, because now once you understand how to structure gas, it becomes an easy equation on how to move this stuff. Much easier than to say we have nothing around us and I have no freaking idea how to start.
Well, I mean, it's important to also say that, along with what we're proposing here, it's not like a Buick that you drive down the highway. When you have a situation where you constructively decoupled yourself, okay, by proxy from the environment, okay, and you've done so while using multi-frequency resonance, okay, that means that your beat frequency resonance of your craft, okay, and first of all, it's not anti-gravity, okay, and I don't want to say that there's no such thing as gravity, or anti-gravity rather, right? But what I do want to say is that it's not what people think it is, okay? And that's because gravity is a property of what we experience in the third dimension when it comes to mass and energy, okay? And if your craft or whatever you're doing, okay, has mass and energy, okay, it's subject to gravity. But what becomes different is what your relationship, the locality of the craft is. And that's what the difference of mass even matters in the first place, you see? Right? So when you all of a sudden remove yourself from the coupling of Earth's gravity by creating a zone, a boundary zone that's neither connected to you, that's connected to it from you, that's not full decoupling, okay? But it's enough that the gravity that does exist now is the gravity of the craft. Okay, so your craft itself is its own, and everything in it is its own gravitational locality. And the implications of that are pretty profound. Okay, because first of all, if you fully decouple, which quite frankly, maybe that's a way. I'm not saying there's not, but total decoupling, okay, would throw you entirely out of phase with where we're at. Okay, if you're decoupled from the environment and then your frequency is also out of phase, uh, that changes time and space entirely. So that's why I'm saying that it's not like cruising down the road in a Buick. This isn't necessarily something that you drive around and, in real time, people are like, wow, look at this thing go. And you're like, yeah, look at this guy looking at me, and it's like, like fortunately / unfortunately, this, decoupling bias, I suppose we'll call it, right? Okay, is actually going to bring you mostly out of phase with what it is that you are. And that means that your time, space, how everything is from the inside out is not going to be the same. So the implications there is that you're not cruising to Mars. You're not like, all right, here we are on our way to Mars. No, like everything should be contracted significantly. Like, kind of to go, like you just kind of point in that direction, then you're there. Like it's it's hard to just explain, and because it's not something that we have experience with actually navigating, like in that regard, it becomes very difficult to say what I mean. But what I'm getting at is that distance is not the same at that point either, right? And time is not the same either. Because now
I was
you
going to say the distance may be the same, but the time is definitely different. Because
I don't think the distance is the same.
you think it's shorter? I'll say this. Here's why I think the time's different. Because you have nothing in your way to stop you. So you can go as fast as you want in that zone, like a highway, right? As fast as you want to get there, okay? And you can arrive there. So the time itself with zero impedance without anything in your way gets you there faster. So how does the distance change?
Well, the distance changes because of what happens when you start traveling at the types of speeds with a decoupling. You see, because this dimension has a speed limit. Okay. Very careful. I was very careful about how I said that. Okay. But it is in direct correlation with the Planck scale. Now, what they try to say is that light has a speed limit. Okay. No, light doesn't have a speed limit. You see, we have an ambient speed limit dimensionally, okay, that is defined by the Planck scale. Okay. Once, yeah, like you cannot travel faster than what it is here. So what you end up with is something there. You cross onto that side of things. See, light doesn't travel at a speed. It just seems like it is because it's already where it is instantly from point of emission to point of interaction. But our reality is only moving so fast to make that correlation of the emission in the first place. Okay, so that's what quantum is. Okay, it's instant on the other side of the veil, and it already happened, but reality is just catching up to it. And how long is perceived to be caught up to is based on your rate of time dilation. And we have an ambient time dilation that exists in all dimensional reality. Okay. And that is defined by the Planck scale. So that's the thing. Like, so how fast can you go? And what does that distance travel mean? Well, it means that if you are not coupled and you start traveling fast, well, the same as the scramjet, you start to be able to bring in a lot more, a lot faster, right? Well, there comes a certain point that gets pierced where you are going faster than the speed limit, and that brings you right to the other side because that's what has got to happen. So when you're on the other side, you see, time and space no longer appears the same as we experience it, and everything kind of compresses. And I don't know how else to kind of say how to navigate that sort of thing. That's
Well,
for a much
I,
larger brain than mine.
I agree with what you're saying. It just seems that the distance didn't change. It's the time that it took you to get through the distance would change. That's you see the distinction there. Like even if time and dilation changed the perception of the time that you go through it, did it change the distance? See, yeah, I know you're saying it's instantly there because you're going so fast, but that doesn't mean that you don't still have the distance to travel. Does that make sense?
I just think that once you go on that other side, that distance is not what we perceive. That's
Okay.
like it doesn't equate the same. There's like a compression situation that occurs. I mean, if you want to think about it this way, think about a cell in your finger. Okay. If it wanted to go and travel to visit its relative cell in your toe, okay, it would have an entire lifetime, you know, and die along the way because to that its distance is exponentially far, right? But if you were to take that cell out from where it is and, all of a sudden it's not relative to its environment anymore, and you just like put it, you place it or drop it or whatever, it could never see the toe from where it was, but it can once you remove it from the body because it's like right there. So
So
there's
the
a drop and then it goes. It's not the same. Like, it's
no,
because
no,
the
that
environment.
only works when you raise your leg high enough so that you shortcut the distance.
Right. Well, when you
So that means
when you're removed from the three-dimensional reality and you're looking at three-dimensional reality, the distances aren't exactly they don't equate the same. So if you're able to navigate like, oh, here, and then boom, that's where you are. I believe. But again, this is that's big brain stuff, man. Like,
I'm just trying to understand. I mean, I understand the analogy. You pull it out up here, move it, and then you move it right back in, and you're out of its stream, and then you put it back in. I understand that, but unless the toe comes closer to the face and you smash it somehow, that distance, you pull it together, that you
I think
can't
that's the point
take the
that I'm trying
distance
to
out
make,
of it.
that the laws of the environment in that analogy, right, of the body, okay, are prohibitive of that to occur, okay, logistically. But if you consider that once you remove it from the body, that the laws are different, okay, then these things can happen in a much different fashion than they would if they were still in the same environment, where they might not have been possible before and may be possible now.
Okay.
I don't know. Like it's tough to give an analogy for something that I'm just talking about having something in one environment under a certain set of conditions, but then taking it away and where you take it to is a whole different set of conditions where it's possible because everything is compressed. That's the best way I could put it.
Okay.
I
If
don't
it
know.
somehow strips your environment while I do it,
Yeah.
I don't know that I understand the other part. I do understand the speed part because it's like we're in a vortex in the universe in our solar system. So if you're the solar system behind us in the vortex, it's faster to get there, yet it's the same distance. But if you try to go against it, it's like sitting in your car and basically trying to spit out the window. You're going to have a hard time spitting in front of you. Going backwards, it's going to go 10 times as fast, right? So you say we can't reach other planets. Well, it depends where they are in the vortex and which way we're traveling. Because once you get out there, you know what I mean? You can travel the ones behind you really fast. The ones in front of you, good luck. You'll have to wait till you get in there. And then now you're going to have to use Joe's analogy of you're on this level of the vortex and you need to get to this level in the vortex. So you're going to have to pull yourself out of the vortex and then insert yourself again in the vortex. Yet the distance traveled is different. And here's why, because you're no longer going around the vortex in the circle. You're going straight through each layer of the vortex in it. You pulled yourself out of one reality, put yourself into another reality. That way I could see the distance of travel changing. Okay. Just like that.
Yep. See,
So
the thing is, and here's the proof of concept. Okay. And it's something I brought up earlier. Okay. There is what they call, okay, a quantum cascade laser. Okay. And something that they use in mostly the laboratory settings, but mostly in military applications. Okay. And now, why is this significant? Well, it's because it's basically um, a very, very high charge laser, okay, at a very hyper specific, not only frequency, but size, okay? It becomes like encrypted in a way because of how the cascading occurs. All right, now what's interesting about these lasers is that they more or less make anything that isn't resonant with it exactly, right? They basically make it so that it's not there as far as its propagation is concerned. So you can shine the laser more or less through something at other things. And it's not until you collapse that laser point, okay, that the emission, is then reflected off of the surface. And once that reflection occurs, okay, the beam is still not there as far as detectability is concerned. You could run spectrums all day long and never see this beam. Okay, but the beam is there at the point of emission and the point of reflection or absorption. That creates entanglement. Okay, and it's through that entanglement that an aircraft can get a laser lock on something. Okay, it's not that it has a laser following it around everywhere that it goes. It's that it was able to find it, and once it engaged it as a target and it locked, okay, it's entangled. So what one thing does, the other thing also does in reverse, which then lets every system that's there know exactly what it needs to do. It's how laser guided missiles more or less work, that have their own onboard lasers like that. You see, and I believe, I can't say, but I do believe that it's also how Ashton's, orbs come to be. Because if you don't need, an object, okay? All you need is two sources, okay, to intercept at the same point. And then one source could basically go away. And then as long as one source of emission stays, okay, then it'll be entangled to that other position. Well, you do that a couple more times, okay, and now all of a sudden you have a circumstance where you have these high energy density levels in midair, taking on more energy density, and and then they're able to interact with each other through coupling. And well, why is that? Well, it's because it's scalar. That's why it can't be detected, is because it goes into a cancellation state, travels through quantum space, quantum space behind the veil, travels behind the veil, okay, as a state of potential, and can be collapsed at any given point, by its own specific frequency. It's how our telecommunications at very, very high levels don't get hacked, because it's variable, okay, and as long as that variability of it goes, it's basically an encryption that is living, because it's working through entanglement. So it can't be figured out because it can't be detected. It's transient.
Well,
This is how this shit works, man. It's
hold
crazy.
on. Let's look at how you can build a laser. You take high voltage and you basically take two rods and you put it out, and the high voltage between the two rods goes back and forth until it goes out and it creates a beam of light. Okay. But now let's bring that down and cut it down to the Planck scale between the two and wrap them, okay, in a 6-pin environment. Now think about that. Now you're taking this and you're bringing it down to the Planck scale in 6 beams of light coming out, okay? And then they're shooting out. So you're basically changing how this energy works, right? It's not going to interact with everything. It's going to interact with the frequency that you're designing it to interact with, right? So they're very specific. They take the metal of your rocket or whatever you have up in the air, and they're matching it and they're exploding it because they're making it unstable. They're basically creating so much turbulence in it, it rips it apart. Okay, immediately as soon as it hits it. So it's a little more to that. But I will say this: the center of the RAV does the same Planck scale thing. Joe and I were talking about it earlier, and this is basically how an atom works, guys. So I'll show you. Oh, sorry, wrong button. Pushing all the buttons today. This is basically so we understand each other. What I'm talking about. This picture represents the inside of an atom, and what you're not. Well, you can see it in there a little bit. You'll see the roundness around it. Like I did the black line there, but inside there's another line right there. And you could see the compression. You can even see it in the outside layering of the dots themselves.
Yep.
So you also would see an electron outside of that. We usually call it just it's a satellite, but it's really all it is pure electricity. It's an electron, and it goes on based on what this is doing. So the reason I say this is because this is in the Planck scale. It's compressing to its smallest value that it can't get out. And based on that, it builds an environmental condition on the outside of it that, creates a zoning. Once it creates a zoning, everything in there goes from very, very super high amount of energy on the inside to very low amount of energy on the outside. But when you're dealing with something that goes in the Planck scale, less is more. And I don't think they understand that. They try to use brute force, which means they're overpowering the center where it can't put the zone together. But it's the compression of the zone itself that creates a tremendous amount of energy.
Yeah. I mean, I agree with that 100%. And I mean, this just goes back to the whole, I'm going to say an old man builds classic line. You know what you don't understand? You know what they don't understand? You know what they get wrong? Well, I'm going to tie this directly now, okay, to light and this idea that a photon even exists, okay, because it doesn't. And the thing is that all light is, and we know this, is a radiation excitation, okay, that's caused, and it only happens in its interaction with matter. It doesn't matter transiently, right? Now, when you look at what we consider a light source or a point of emission, this is going to sound weird, but hang with me here, okay? Even if it's something simple like a light bulb in your house, okay? That light that you're looking at there, okay, is just really the opening of that excitation, all right? Now, it's nothing in between you and it until it hits you. Okay. That's why and then you cast a shadow. And all it is radiation. There's ways to cohere light, obviously, but why most light is white is because it's not deterministic as to what it's going to show until it's reflected, which is based on the matter interaction and how um, radiation frequency is going to interact with that surface. And that's why you can have, for instance, the sun, you would look at it and generally say that it has an infrared bias. Well, why? Well, it has an infrared bias because the exchange from the point of emission, okay, as I've said in the past, it leaves a footprint behind dimensionally, right? And that footprint that it leaves behind is what we consider conservation. It leaves it behind as heat, as thermal energy. So what it's taking back with it and what it leaves behind, it evades our detection for that reason. Okay. But the fact is that it leaves as that. Now, it only comes back when that energy that's radiant off of it that it left behind, okay, then comes into a relationship with something else. Even though that thermal energy or that radiant energy as well, that comes off of it falls in a very specific light spectrum, what you end up getting is white light out the end. And that's because because it's not predetermined, what the reflection of it's going to be. So how it manifests on the other side as a reflection or refraction is wholly dependent on the radiation's interactive oscillation, okay, with the material it's interacting with. So in other words, when the radiation hits the particular the particular material, okay, it's going to cause a certain frequency of excitation that's going to fall within the visible spectrum. Okay, but the determining factor of that is the material. All right, and all that's saying is that it induced that potential, that was transient potential, into that particular oscillatory rate that then you reflect and see. So it's not it's not how they make it sound. It's just that it doesn't know what it's going to interact with, and because there's leftovers, well, it could break out into spectrums from its reflection.
Nice. I love how light works, man. So much different than what people think.
Oh, so much different. So much different.
So Joe and I were talking earlier, and I don't remember the device's name, but basically we wanted to use a camera to be able to see gases. And I'm sure everybody in the chat's seen it and seen the videos. I think VE was the channel that did it. I don't remember the name of it. But he basically used convex mirror, so inward in round, okay? Not the one that pops out, but the one that goes inward. And they use a razor blade, and then they use a point of light. So just an LED over here taped around it, so you get one point of light emission. It goes and bounces off of the mirror, comes back into the center of the camera lens, right? And that allows it to be able, when you turn off the lights, to see the gases that go on, okay? Now, with that device right there, we're able to see something in the gravity flyer that you wouldn't normally see. So the piezo disc puts off layers of sound. And each one of those layers of sound interact once you bounce it off of a solid surface. So they showed this on YouTube, and you've probably seen a piezo transistor or basically one of those things for your sonic water machine. You put it on there, and then it makes a sound wave. It hits the top, and then it bounces back. Well, now you're in interaction with it. So let's look at what Alexei did. He took the energy of the Tesla coil, he hit it, and bounced it back off of it. That's why you get the extra sound. So let's just understand what he's doing there. He has now coupled the energy of the sound with the energy of the Tesla coil, which is the environmental condition of the gas, and has now bumped it. And he's bumping it. What did I tell you about propulsion? We take the eye shape into the donut shape and we make the cone. That right there should give you every answer you need to know on how they did the vector direction and the gravity flyer and made the lift portion. It is not, however, the gravity well you have to create with the outside field. It is simply the portion where it has a direction of energy pushed in certain ways.
Yep.
So just,
Now I will throw it out there, and you have
Go
the
ahead.
photo, so we can show them. But now I developed a way, okay, using nothing more than a camera phone, okay, to be able to, within reason, okay, predict your field geometries and your floats and your vector directions. And the way that I did this was, first of all, there's an ideal way to do it, and then there's just the way to do it. Okay, but we'll talk about the way to do it. If you take a photo of something that has a magnetic field, all right, what we said was, well, light. What's light? And light is, just energy, radiant energy, and just like any radiant energy, it's subject to the magnetism and the electromagnetic flows in a given area. That's just the way of it, right? Well, so that since that's the case, what you could do is you could take a photo and you could sharpen it repeatedly. Okay, full sharpen repeatedly. And what this does is it concentrates the sensor data, okay, to its most obscure form in terms of every differential that exists between pixels. Okay, and that includes photon bias. Now, if you're able to sit there and sharpen these images to the point where these photon biases become apparent, and to me they are, and I'm sure to many people they look at it and be like, I don't see what the hell you're saying, but hang with me here. All right, you take that and you hold that data, then you take the same base photo and you blow up your color saturations, okay, to basically take everything, be the most refined version of the average color in the area. So it brings out some of the spectrum that you kind of wouldn't see or you missed. All right. Then, if you're like me, you could just superimpose these images on top of each other and tell a whole lot about it. Okay. But you could actually take it one step further. And this is where AI is actually great. Okay. You kind of tell the AI sort of what you're doing. Okay. You provide the image that shows the vector directions. Okay. And you say, please use this camera sensor data, you know, and basically find the photonic vector directions, and if you prompt it properly and you provide the image and say create an image displaying, accurately that data, it will actually find all of the biases and connect the points and then provide you with a feedback image of what that field geometry looks like. Now, if you take that AI image and then you do an overlay over your own images, you can literally visualize the field with what I'm going to say is probably a fair degree of accuracy, because it knew nothing about what the fuck was going on with the pictures that we gave it. Okay. And I didn't give it the base photo at all, but it was able to map out what I would have assumed predictably would have been about the field patterns and interactions. So it's seemingly like a very good procedure. Now, I mean, if you want to show what I'm talking about.
Yeah, we'll give me just a second, Joe, if you don't mind. I want to thank you, Ulysses, man. $20 sticker, man. Really do appreciate that, brother. Thank you. I gifted 5 Men's Bills memberships, man. Enjoy them. I want to thank Darren, man. $5 sticker. Thank you very much, brother. You guys always take care of me. I just want to say special thanks to both of you guys, man. Totally awesome. So I'll pull that up for you, Joe. Just give me a second.
Sure.
Wrong one. Okay. So you want, let's see which one it is first.
Well, yeah, you could show all of them or whatever, but I'll explain each one briefly.
Yeah, let me show this one first. Okay. There you go. That way they get an idea of what you're doing first.
Okay, cool. So, what I noticed from some of Alexi's videos, all right, were that his gravel flyer, especially on takeoff, okay, had what was apparent to me, but was really a trained eye thing. I think it had what seemed to be a distortion that was around the craft as it began to lift off. Okay. So I underwent the process here. This one was done with no AI whatsoever. Okay. This was a manual process. And I was able to accentuate, the field the energy that was going on around the craft, as well as point out some different biases in the surrounding environment. Okay, just from that one photo alone. So as you see top right of his gravel flyer, you could see that there's a hot flash right there, big time. And it's radiating out on that side, and as you would kind of expect, because this was literally about to lift off at that moment, it was still empty or on the side, but you could still see where there's a big color difference and lightness difference right around that edge. And that was all pulled out by the process that I described to you, and then completing an overlay in Photoshop of just one image on top of the other. It brought out both the color and the vector biases.
So let's take a look here.
So that is when I ran the raw data through AI, and it, again, the raw data looks nothing like a gravity, anything. I didn't tell it what it was trying to do. I didn't tell it was electromagnetic or what it had going on. Well, these look like the same exact field geometries that I drew earlier that are required to make something lift. So, this is what it found independently of what I already kind of knew, which was pretty neat.
Let's see. I just showed that one.
Okay. Well, no, you can go back to that one. That's good. So
okay.
that's what the image looks like after I'm done manipulating it to bring out the vector biases. So you could see that there's not much of an image there at all. Okay.
Okay. And then we see the next one.
Yes. So now this one is the full overlay of that process. Okay. Combined with the AI generated flows that it found from its vector analysis. So now you could see what it postulated the flow would be, and as you could see in this configuration, Sean had a slinky as the anode, and it knows that the energy is coming right off that bottom band. Okay, it could see that, and it could see that there's a polarity bias that's starting to occur that causes the swirl. Okay, and as we know, it convenes at that bottleneck, because as we're aware, we know that the mass differential is a huge component and the deterministic factor of the anode and cathode, and that's where you would expect that convergence to occur. And if you look at how I proposed in the past that the RAB is built in the first place, you would see these same geometries. Now, what you end up seeing is it was able to pick up on the arcing, okay, and was also able to, I don't know what just happened. Yeah, it was able to pick up on the arcing, but it also shows the same exact geometries that we observed with our own two eyes when Sean did this and the yin yang popped up. So it has all that same thing, and it was able to find this through the photonic vector biasing, and that was its result there.
That's so cool. It was a good process, Joe.
Yeah, man. I used my noggin one time. Yeah, and that was just me tracing something out to Nathan, just trying to show him, like, yeah, look, it's pulling it in right there, and that's its that's where it's creating that barrier that I was describing earlier. So it's just creating that static barrier that interacts with the environment, right? Well, that's it getting hot right there on liftoff.
What's great about this is you say it's a liftoff, so you can see where the energy pushed it. You know what I mean? It's hotter on the top, colder on the bottom, and whoop, it's hitting towards the hot energy. That's cool.
Yeah, it did one of these.
Yeah.
And now that makes sense because the flow patterns here, okay, are based on helicity. Helicity is rotational, and rotational means that when you're going around a two-dimensional flat circle like that, like as the center plate, it's going to create a wobble before it stabilizes because the helicity is building up as it wraps around. So when it pulled, it didn't just float right up. In order for it to break that locality with the ground, it had to break it somewhat to create another bias, and then break it another way to break it free. As soon as it broke free, that flare goes away and it levels out, and then that's it. That's the deal at that point.
Wow, that's so cool because the rotating magnets, how do I say this? I think Luftwaffe or whatever his name was, Luftwaffe, the old guy with the anti-gravitic stuff, he basically took a 25-pound weight, put it on bars, spun it up to, several thousand or 4,000 RPM, something like that. And it became not weightless, but it just set in his environment differently. So the guy holding the pole wasn't holding the weight. It was the weight was in this direction. That's exactly what that gravity flyer does with that spinning magnetic plate that's underneath it. The magnets do the same thing. So as it goes in a direction like this, it wants to balance itself back out like this. So it automatically acts like there's a pull to the ground and levels itself back out. That's so cool.
My understanding from the get-go was because he's using actual spinning inertial mass, right? Is that when he hits the buzzer, it goes into a stall, and that stall automatically creates a invariation, aka a balance issue.
Yeah.
Right. Center of gravity changes, causing the tilt. But now, as soon as that tilt is combined with an amplification event, okay, it has enough of a differential to find its new ground state. Right. So it's going to go path of least resistance. Well, it's more resistant to go through only part of it on the ground than it is just to connect to its virtual ground state. So then it connects to the virtual ground state. And now all of a sudden it doesn't have that relationship any longer with its initial ground state being the Earth. So it is at that moment decoupling, and you could see it right there because it's still partially coupled in that moment.
Yeah.
So
cool. But that's why his craft is all janky and loose, because it's shifting the weight in order to create that angle, right? So then it can fix itself. So if it's too stiff, you can never get it to go and push to the angle at all, because you have too much force to push over. But when it's janky and the thing's all loose, then loosey-goosey, man, and it'll whoop right up on its side. I think that's so funny, man. The part that everybody thinks is trash is actually the smartest part of it all.
Yeah, I mean, it's still not the way I would ever choose to do it for so many various reasons, but I get it. And frankly, if it wasn't for that and your work on that and everything that we've cumulatively amassed over the last 2 years of working together and so on, the fundamentals would not have been there to make the connections to see a better way. So,
yeah, well, you got to start somewhere. It's like the entry level craft for everybody. You get into it, find out how electricity works, find out how Tesla coil works, and you take a deep dive in all of them. And then you go and you hold your head for a while in a very small room that's dark. And then when you finally emerge, you might have something better to try. So, sorry to say, man, but that's the way it is. I worked on that thing for 1.5 years straight, and I just I had to get away for a little bit because it was becoming too much. I had to re-see it the right way. Dylan, I want to say thank you, brother. I really do appreciate taking care of me today, my friend.
Thank you, sir. Much appreciated.
But this, by the way, is another reason we're getting back into the gravity flyer, guys. Some people think, well, you're done with it. No, I just put it on hold for a little bit because we had to have a little more information. A couple of the things we're bringing to it is I'm going to buy that disc and we're going to show that gas thing so you can see where things go. And I want to see if it matches Joe's picture. Okay. You know what I mean? I want to see, we're going to compare. We're going to see if the bubble builds around it. We're going to be able to see it in the gas. That's awesome because you see the gas in the environment when we put the smoke. I put the smoke there and I couldn't find it. So I want to see if it's going to show up in that cool image. Okay. Another thing, man, Lightspeed's building us that sensor array. So we're going to be able to see something very awesome in that. And it's going to give us a picture into what's going on here, man. And look, I'll be the first one to say it. I can be wrong at any time, and I'll go with what the experiment says that it is. You know what I mean? Because the data's not going to lie to me. It's just going to tell me what it is. And we got to find out if we're doing it right or doing it wrong and how we change things to make it right. And I think there's going to be a lot of opinion for everybody in the chat, everybody who watches the channel on exactly how to fix it. Okay. Because we don't need to change so much everything on it. We just need to change the understanding of what we're doing. And I think having the right tools is going to be a very big part of that. I couldn't get there, man, without the audience and stuff in here, man, at all. So just thank you guys for, sticking in there with me and everything, because it makes a huge difference in what we're doing.
It definitely does. And it's always the discussions that we have and then the input and, us bouncing off of the community here that, allows us to open our mind into new directions, and, I'm going to frame this as a good thing, but I know it's a terrible thing. Okay. Like, sometimes people will say something and I'm listening, but like it doesn't register or whatever. But sometimes people will say something and it registers and I don't agree. But then sometimes there's this one little piece that's like, I'll describe that little piece. And then I let myself go out on my own damn tangent on it. Now, it doesn't mean that person's not right, and frankly, it doesn't, like, I hate to say it, it makes me have lack of attention sometimes when I'm watching something to learn something because I'm not really getting what they're saying out of it, because I just listen to what they have to say and then think my own thing about it, good, bad, or otherwise. But running with these little tiny things have taken and had me self-discover so many things that when I start to talk to, like, I'll be like, hey, you know what, I figured out XYZ, but combined with this too, XYZ. And Nathan's like, it starts name dropping. Oh, like this. Oh, with that, paired with that. And I'm like, yeah, if you say so, buddy. And it's that thought process of, being able to self-discover these things sometimes that makes you have this most fundamental understanding of something, whether you're right or wrong. Sometimes it takes you down a trippy road and you're just like, what was I thinking? But other times, it really opens up a whole entire world, and not being stuck in the box of where physics is stuck currently, okay, is really the key. Because everything here, whether it's theoretical or actually in engineering, all these things are purposefully kept compartmentalized. And it almost seems like making a correlation between this and that is often the most sacrilege thing that you can do, or people don't see it because they're just so hyper focused on one item and one discipline that looking outside of it for answers doesn't occur to them. And that's the box that Nathan and I have both kept ourselves out of.
Mm-hmm.
And it's been a way that rather than I realized from an early time of starting to think about this stuff that trying to come out with some kind of why physics is wrong reason is never going to be the way forward. It's never the way forward. And they have data to show if you deviate too far from the things that they're saying, why you're inherently wrong. But the answers aren't there because they're wrong. The answers are there because of the gaps. You know,
Well, hold on. Let me say this. Physics always says you're wrong in the beginning until you pound it over their head and see it's right. And it's the gaps that they missed is where the information is. We learned in the RAV their idea of plasma physics is somewhat tainted because they're seeing it 5 seconds at a time. We see the RAV for 20, 30 minutes at a time when we're like, this is totally different than what you're saying, though it falls in line with most of the explanation you're giving. There's just more there.
there's more there. And, you know, this is where, I mean, not trying to give myself credit for all too much, but this is where I'm good, is if something's not there, that's just as important as it being there, and understanding the processes to a certain degree allows you to figure out where it is, what it's doing, because like everything else, it's never really missing. It's just not where you're looking. And, you know, sometimes just because it's not detectable or it's not what you see or it's not what you observe, doesn't mean that it's not the key fundamental part. So, you can sit there and try to measure and be like, oh, we got this on a detector. Cool. But there's more that's not detectable than there is detectable. So until you concede to that understanding and start to bridge the gap in what you know,
Yeah.
then
Hey,
it's just a big mystery. Then it's strange action at a distance, right?
spooky at a distance.
Spooky action at a distance, yeah.
I want to say a shout out real quick to Darren out there. Hey, wish you all the best wishes, man. Just got out of the hospital, man. Hopefully everything's going well. I know you went through a surgery a little while back, man. So, like I said, hopefully everything's going well, man. We all wish you the best wishes.
Right on,
And
man.
then I want to say real quick the answer to this question. How about your battery? How's it doing? All I'm waiting for is Bernie to come back. He asked me to wait for him to load it up. It's completely built. It's ready to go. The only thing I didn't do in there is, like I said, we're going to use orange slices this time. So I just got to take the fresh oranges off the tree, slice them, put the juice in there, and then it's ready to go, man. So he asked me to wait for him, and I'm going to wait for him, and then we'll see where it goes. We'll see what changes we'll have to make to it.
Yeah. I don't know. The tires has been on fire this whole episode and haven't paid him any mind, so I apologize. He's on the up and down version over there, but a lot of good points that he made. It says that he found pilot wave theory. Oh, that's cool and interesting. And pilot wave theory actually is a big part of what I was talking about earlier with the redesign of the flyer, if you want to call it that, because the whole idea is this potential to frequency situation with carriers, and it doesn't happen in the obvious way necessarily, but I think it works out, where you could have AC and DC riding with frequency and no frequency with just densities and potential. You see, it's really, really rad how that goes. And what you end up with in that type of circumstance, in my opinion, at least when you're dealing with, and Nathan said it all along, although I don't, even though we had an understanding, explaining it to this degree of like this, being specific, was hard because he said well, an asymmetric capacitor. And then at another point in time, he's like, well, it's like a leaky capacitor. Well, right, it's an asymmetric leaky capacitor. It's both. And that's the idea, right? is that there's two sides to the coin, but the core of it and what's running it is actually all the same. Like that process is the same. It's just about revectoring energy, and rather than forcing rectification, having what you're trying to induce be the circuit, you know? And when you have what you're trying to induce be the circuit and rectify it, now you're in business. Now you're in business.
I want to say real quick, Joe, a shout out Yanni here. On my other channel, guys, I do the Bedini, and I've been showing all the work on it. So if you guys missed any of that, it's on my other channel. Okay, it's in the description. It's the podcast channel or Coil channel, whichever one I have on there in there. So he was giving me some advice on it, and I took his advice. So I had to put a potentiometer on this thing, and I was getting half a watt hardware, and it wasn't good enough. It wasn't going to stand up to the pounding. So I got a 2-watt potentiometer, and it helped part of it. It gave me the coarse tuning, but Yanni had suggested, hey, get a smaller one and do the fine tuning. So I just ordered that one. It's a 500 ohm, 10 turn, so fine tuning. So we have coarse tuning and fine tuning on it. And then all of the resistors were half of a watt as well. So I'm going to bump that up to a 2-watt, all of those, because if you've been watching it, I've been having a little trouble with things burning up on it. So to correct that, we changed the wattage in the resistors themselves in order to get them to basically be tougher in the circuit so they can take more of a pounding. Now, we're getting plenty of energy running through this thing, man. 18, 19 volts out of a 12-volt start system. That's pretty good. My concern is it's just converting some of the amperage to voltage, and it's not giving me the spikes. So in order to get the spikes, we got to get the hardware set up the correct way. The cool thing about it is it enabled me to go in and build some STL files in order to put the 2 potentiometer knobs on the side right there, so they'll look really cool when it's done, but they have a function in the circuit. So I'm really happy about this. And let me just say this: I'm publishing all the results on it, good or bad, so that if you're having a hard time with this, it's very simple. You just watch and see all the mistakes that I make, then don't make them. You know what I mean? Or you could say, hey, that particular mistake, that's what he had, so how did he solve it, right? Just a way to kind of get everybody in tune with it. And it's, I pay for my mistake, so you don't have to pay for yours. And if you understand that, then it all goes out there, and you guys all get to learn about the Bedini circuit and then what it's going to be capable of doing. We're also doing the pulse motor on there with Mike, so I have another setup that is going to be a building setup going on in there. So I have the one that's perfect, and I just honestly, it looks clean, it looks beautiful, and it runs every time. I just want to put it to the side, and I want to build one more. And I already have the the round part and everything, and I'm doing that for a reason, because I'm going to change a lot of things in there. And before I'm done, this thing will run on dead batteries. So it's going to be cool. But I don't want to mess up the original one that I had in doing it. But I'm going to up the size of it. I'm going to use some different techniques on it. So we're going to put more weight on the outside of the wheel, less weight on the inside of the wheel. And, you know what I mean? We're going to make more of a flywheel out of the center part as the pulse motor. You know what I mean? Change some of the coils on the outside. We're going to change how much energy goes into the coil so that we can get more out of the coil by using reactance to it. We'll change the inside core to barium tighten it so we can get a fast capacitor on the inside. So it fills that core quick, releases the energy quick out of it. Okay. So we'll be able to pull bigger spikes out of this thing. Just some cool stuff, man, going on the other channel. I just thought I'd tell everybody about. So.
Very cool.
I'll go ahead and drop that link just for everybody.
Also, a little preview of what we got coming up soon for you guys. We're going to be talking about the light effects of the RAV on the next episode of Plasma Unleashed, which is going to be pretty cool. Also, for those interested, mild change of format, that's going to probably keep it a little bit more streamlined and a little bit more focused on like the videos and just us the explaining what's going on and sharing our experience with it over the videos. So That's going to be cool too, because you'll get a better up close look at the work that's actually being discussed. And uh, for anybody that's been following Rab, which pretty much is everybody, I'm pretty sure at this point, there's been some really, really phenomenal light phenomena. Um, some stuff that we know exactly what's going on and identifies it for exactly what it is, and other stuff that's just so strange that we could only speculate. Like,
Oh yeah.
we could only speculate what it probably is. And I'd be fast to pull some kind of theory out of my ass. But and I'll probably do that. But to say that with any sort of certainty would be an absolute fabrication, because there's not a physicist on this planet that would be able to look at that and explain what's going on. So
It's funny.
yeah, love it.
I love it, Joe. Guys, real quick, CBK, we're going to be in talks for Monday's show. Hopefully he comes on, man. Got some awesome stuff that goes on with the Tesla coils. So I want to be able to show that. We showed some of his work on the channel before. Victor, let's hook up for Friday if you want to. Me, you, and Joe can hang out, man, and talk about all the stuff, man. I'm totally into it if you are. So I'll hit you up on the email.
Yeah, link up with us. We'd be like very, very excited to have you back on, and see what's going on, because there's always good stuff going on here. Now, I know Sean's been up to some stuff too that that we haven't shown. I don't know if he was ready for us to show it or not. I have no idea. But
I don't know. He's been kind of in and out of it lately. He, hasn't been doing all that well. So wish him the best. Yeah. I want to see him back on and healthy, man. So as soon as he's ready or whatever he wants to do, by all means,
I'll offer. Give the audience anyway a little bit of insight into it. He moved on to putting the Rab in quartz again, like I did, and he chose to use one of the approaches I suggested, and it seems to be successful. Like, no quartz blowing apart into pieces, and the Rab is definitely inside. I'll tell you that much.
Nice.
Yeah. So, what that ultimately means for the end game of things, I guess, is yet to be seen. But I know that that's something that, a lot of viewers and stuff have been into, seeing that happen. And, what you end up seeing is that there's a small channel that allows for the passage, right? Like we suggested. But the Rab grows out much larger than the small channel. And
we're just saying that Joe called it right the whole time, and Sean's proven it out. So I don't know how much Sean wants to share that yet.
Yeah, but just know that it's happening, and when we show the footage and break it all down and all that good stuff, I'll do the new imaging on it too, because it'd be really, really, really cool to see, what the fields look like, with the excitation of the piezoelectric, which, by the way, I pulled a little bit of a Sean, and I named that photo technique because it's not a known photo technique for this purpose. And I'm calling it BBM testing. Okay. So if I refer to BBM, that's what I mean. And that stands for vector bias mapping. It seems like a pretty nice common sense, thing to name it. So vector bias mapping, and in fact, if you have more photos, there was a couple more photos. There was one that I sent of something else. No, did I not?
I don't know right offhand, Joe. It'll take a while to look it up.
Yeah.
I shared those ones with the Gravify group so that they could take a look at it.
There was one other one, I think, of
Spark Out.
It was of the Rab preformation and self-nucleating cathode.
Give me 1 second, Joe. Just
and
one
that
second.
one was the really impressive thing, because you see all the stuff we were talking about. Yeah.
And there we go. We should have it.
So
I
that was
wish it was bigger.
yeah, that's the original photo. Cool. So that's the stock photo that I used from the video. That was it after I vector biased it. That was hard to see. Okay, that's with the color bias. And then this is the one with the vector biasing put on top, superimposed on top of it all. Okay, so you could literally see the flow patterns as they are building out and wrapping around and feeding into the cathode and how they're doing that. You could see the yin yang in that as well.
Nice. That's so cool.
Yeah.
You see all the flow patterns in it.
You can see exactly more or less where the energies are going and what they're doing at that given moment. Now, since it's not fully formed, right, these flow patterns are building in coherence, right? They're building up their coherence. So they haven't reached those predictable shapes yet, but these are still the shapes that we would expect to see at this stage and the ones that we somewhat observe. And it really just goes to show how accurate this seems to be. Really, really impressed with it.
Nice.
Yeah, thank you, Ulysses. I appreciate that, man.
Shout out Sean. What's up, brother? Sean's in the chat. Oh man. Okay. Sean
Well
says
done,
we can share whatever we want. Okay. Give me 1 second, guys. Yeah, Joe, I think your whole thing's doing awesome, brother, and you got the right technique for all of it, man.
Yep. I knew it was there. I just had to find it.
Oh man.
Wow, Sean. Really? Thank you, bro. That's cool.
Oh, dude, I gotta show this. Oh, dude, Sean, you're awesome, brother. There's nobody like this guy.
No,
Thank you, Sean. I really do appreciate it, man. Making my day, my friend. I'm hoping you're doing well. Hope to speak to you really soon after this. So, right on, man. Hey, I wanna share this too, Joe, real quick. This is Mike Faraday. He was over there messing around with a pyramid, and he did it right under his high voltage line. So, was the pyramid picking up a little extra energy? Yes. So he has this little dot, and you can see it upper left in the circle. And basically, what was going on here is he's focusing light. So it looks like a little plasma in the sky. What it is if when you guys see the RAV experiments, you see the little light balls going on. This is light balls inside the environment. So I just wanted to show that. Mike's out there in his Indian outfit, man, doing rain dances over there with his little triangle, creating this stuff, man. But that's what he's got going on there. And every time he does it, it's focusing the light to the point of the pyramid, which is totally awesome in itself. But I just thought I'd tell you what it was that he was doing, because we see it all the time. So we're used to seeing the image here of, like a little light color or whatever it is, and you see it every time you're in the RAV experiments.
We absolutely see that all the time, just like you said. And it's interesting to see. You see, like that pyramid works through induction, so it induces it, and then it projects it. But the phase that it projects it in is a scalar phase. Okay, yeah. And it again is not collapsed in any sort of way. It's not something you could pick up with a sensor or something like that as it's coming off of it. But as it's going to hit something that's in resonance with it, it's going to collapse, and it's going to do that as it goes through the atmosphere and finds that frequency band that it's in tune with, and that's what's pretty neat. It very, very cool too. Like you can't make that stuff up.
No, you can't. I just thought it was really interesting, man. He's got a bunch more pictures on that. I'll ask him.
He thought it was the UFO that was. He's like, every time I do this stuff, the UFO comes.
That's so great.
It's
I
like
love
when people say that they summon UFOs. Okay, so now we're on to Sean's Ragnarok.
Look at that.
Now there's definitely stuff going on there,
Oh yeah. So is that crystal, Joe? Did he put it through?
That was my impression.
So interesting.
Unless it was a glass bead, I thought it was a quartz bead or something like that. We need
Okay.
to clarify, but I thought it was quartz.
Hang on, right here. Look into the quartz itself. There are 3 rafts that are built in there. Do you see them?
Yep.
Right
That
at
might
the
also be the
top.
reflection of the one though. So I would the refractive index of quartz is different than glass and water and stuff, So if it is
Okay, well,
quartz,
let's
you're
follow
probably
it
seeing a
then.
reflection.
Yeah, let's follow it then, because you can see them starting to build right now, right? Right on the top of the glass tube, right there where the energy comes in, we see those 3 dots.
Okay. So he says it's quartz glass. So quartz glass is quartz, okay, but it is not piezoelectric. So, there's amplification that could occur in a natural quartz or man-made quartz crystal, but quartz glass is going to be more resilient than glass is any day. It's not going to etch it up the same and such. So it's definitely a good medium.
Well, take a look at those, Joe. I mean, we should slow this down and zoom it in if we could. They're pulling up. If they're the reflection of it, it's doing it in sequences.
Mm-hmm.
But it's like a fuse that goes off. Watch, they go, and then boom, 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 they go up all the way to the top.
That's very cool. The one thing I wasn't sure about is if the tube that it was in, see right now it looks pretty empty. In other tests that I saw him running, the tube was more full with water. So I wasn't sure if that was a variable he was playing with or what where that was at.
Look at that. He's got like a quasar light coming out of it. It's just like going straight through it. You might be right. It might be the reflection of it on the inside. It's creating one light.
I mean, as Sean says, there's multiple, and he's the one that's there. So I'm not going to doubt the person who makes it and has eyes on it. But I do know that the illusion exists, with the refractive index. Where if you have one thing, you're going to see it here, here, and here around the surface, through the side, because since it's transparent, you're peering through the curved side, where it's also reflecting on that side too. So even if you're looking at it, you see multiple, it's possible that it still is only one. But again, he has eyes on it, so I defer to, what he says goes.
Yeah. It looks like 3, Joe.
It does.
And it could
does.
be more.
And it should. I mean, I agree.
Hang on. Oh, I love that picture, by the way. Sean sent that to me. Look at the zoning that goes on in that, Joe.
Oh, yeah.
Look at the secondary zoning. So the center of the center object has one zone. Then there's another zone that builds out from that, but connects to the outer zone of the second level of that zone. And then it goes straight through. And so weird.
That looks like the thing from Stranger Things, man. The Demogorgon, It looks like the mouth of the just like.
Yeah. Here's the thing.
That's one of the coolest shots, man.
Yeah, it's streaming like a laser straight through it. So when I say it's lensing, it's basically like a magnifying glass. So you see the green dot there with the eye look inside of it, and then the eye right under it. Every time it's hitting one of those sheath zone, and you could see them on the left and right around it, and it's building up right on that zone, you see that it's focusing it. And then it found something at the very bottom and built an environmental condition around it in a circle. So I just want to show that to people so they understand what we're looking at here. It's literally focusing light, even though people say it's a camera angle, but it's not, or a camera thing. It can't be if the environment itself is reacting to it. It's showing us what the environment is. Even if we can't see it with our own eyes, the camera can. And it's showing a distinct direction to it.
Not to mention, you see how bright that is?
Yeah.
Like, you see how bright that is? Where's the environmental illumination? Where's exactly? Because it's in compression. This is what a portal looks like. I know that it sounds weird, but you know, this is what a portal looks like, and that's what this type of light emission is. Because it's not really emitting; it's just opening a gateway of the energy
Yeah.
flow at that point. It's not emitting out. It's just simply you peering into that high energy state that's being allowed to flow in without normal resistance under, and it's held in by compression. You know,
Oh, check this out, Joe. Sorry. Where is, see, you have the big ring up top. Underneath it, you have a secondary ring, okay? That has like a lighter color or darker color, I should say, underneath it. Look where the center of it is. So you see the green dot? This green dot is close to the center of where that's building out, and it builds out that little satellite right there on that sheath layer. Dude, that's amazing.
it is, and I'm gonna need you to send me the screenshot because I don't think that I got it, or if I did, I didn't see it.
And Sean's creating a dark light. Look, on the
That's what
outside,
I'm
he's
saying about the
creating a
dark
dark light. Oh, dude, this is so fascinating. I love this picture. I have one of his experiment that I took a while back, man, but this is just out of sight. Because you finally get to see every time this thing amplifies, those rings that you're seeing around it, they're always there. But like a photon, they don't do anything to show you the light until they reach a higher energy potential. Then the light bursts out of them. Okay?
See,
But they're always there.
you saw what I saw, man. This is like DMT entity territory. You know, like there's physical form in that, and I mean, you know, that is what it is. I'll break it down and show you guys the goods when I'll manipulate it in every way that I know how to bring out all the forms. But it's a very cool and unusual thing to see. You know,
Yeah. Oh,
staring straight into the hole, man.
okay, Sean. We had another video of Sean. I wanted to bring that up. I just wanted to show that. That was cool. Let's see which one it's on. I got so many things open on this. Sorry, it's this one.
Oh yeah. You could see the resistance that is building up as the saturation occurs, or lack of resistance,
Mm-hmm.
because it's able to actually transmit its arc without arcing when that level of saturation is reached.
I want to show this or say this so you guys understand. Hutchinson did this a while back, but his arc was going on the outside of the crystal. Sean's is going through the crystal. So just in case you want to look at the two experiments side by side, you can see what the difference is. By the way, we just saw a cool part.
There you go.
Right at the very end.
Right there, it just stabilized finally because the saturation levels got high enough. So that's exactly what I was saying earlier. That's why the arc disappeared on the cathode side. Very cool.
Oh, he's definitely, look, he's got 3 streamers coming out of that. Do you see him?
Mm-hmm.
Look at that.
But now look at where it kills off. And what's important to see, okay, is when it goes away, you freeze frame it. And then you see what the hell is going on as a result of it going away. Those are the moments that I always look for to examine,
Yeah, he's exciting that crystal from the inside too, just like you did, and got all the color from it.
Yep.
That's wild. Oh, I love that. Sorry, guys. I am just a plasma fan no matter what is going on.
So look, you see how it went kaput? Conditions were set, rab formed. And look at the frequency change when that happens. So you have this orangey yellow gold, right? And then once it goes kaput and then it goes into stable mode, stops arcing over to the cathode, it goes white light.
That's so cool.
I don't know. I saw the white light a second ago. I don't know where the frame is.
Clicking around. There it is. Right
Yeah.
there. There's the white light. Wow. That's so cool. You know what? I wouldn't even think that it'd be white, Joe. But then I saw the dark light. You know what I mean? So I'm going, oh, wow, there are all different colors out there, and the background is pretty much irrelevant. They're all going to show up. So that's one of the things that tripped me out, too, that dark light got me. Because it was like a foggy mist of dark. So, oh, Sean, always, man. Always.
Oh, yeah.
Let's see, we got one more here. There's that white light already, Joe, before I even hit play.
Oh, yeah.
And it's got two beams coming through it.
Mm-hmm. 3. 4.
Wow.
Something. There's more than one. But now look at the light refraction, okay, as it's coming through. You could actually see it tracing with the cathodic flow, which, I mean, I can at least. It's easy to see those things in motion because it looks like it's reflecting through water, okay, and the glass should put out a more coherent pattern than that as far as where the light emission is coming from.
Oh, look at that. Hold on. That is where it gets me. Look at that.
Yeah.
That is so cool.
Now this one's putting a good amount of light out into the environment, which, you know, that's, I don't know what the difference is there. I mean, I know what the difference is in theory, but I mean, what is the difference in the structure and configuration?
I don't know, man. That's pretty cool, though. He could be getting a different answer because the tube itself is round. And because that's a cathode, it may change the condition. Yeah, that's just cool. Yeah, most people just put their crystals on their shelves. Not on this show.
Never. Never except for when we do, I suppose, but nonetheless.
Yeah, we just put them through torture and high voltage all day. Huh. That's so cool. You imagine that, Joe? You go into a crystal shop. What are you going to do with your crystal, man? You going to put it up? You got a nice display? Oh, yeah. I definitely got a nice display, all right.
That's it.
Hey, shout out right here. Magneto Freako, he's been helping me out with my Esty as well, man. Totally awesome guy, man. Been hooking me up on stuff. Thank you, brother. I appreciate it, man. Let's see. The rod dances inside the quartz for as long as give it power. Nice. Hey, Sean, you have a time that you put that thing in there for and leave it? Like, does it go on for like 20 minutes if you let it? It's kind of interesting. Right on, brother. Right on.
All right. What does Steven say? He says, just for shits and giggles, that I should line up that last beautiful screenshot with the structure of the inside of the pyramid and their tunnels. Yeah, I mean, listen, that's a good point. And you know what, I should do stuff like that. I mean, and aside from that, you know, it'd be interesting to take a high resolution photo of the pyramids, you know, and see if I can manipulate it and do my photo process to see if anything comes out on it in the first place. That'd be kind of cool too. Um,
I'd love to see it at like during a rainstorm, during the pause in the rainstorm. You know what I mean? Where it's
yeah, when
probably
everything's
most energetic.
I mean, who knows if and what it puts off anymore, but it's probably more than nothing, right? Um, and
Well, hold on.
something like that.
It's if it's filled with water, okay, and all the stone gets filled up all the way. No matter what, it's creating a shorter distance between it and the sky. So the energy level of it has capacitance in it. So it should put off some kind of a field. So that's why I say around a rainstorm, because when it's dry, it probably doesn't do anything. They made these things to take lightning strikes.
Yep.
You know what I mean?
Yeah, for sure. Another thing too about VBM testing that at this point I only guess, but I kind of am confident in is that using raw format, if you're taking a photo, is going to give you the best possible results because that's bypassing algorithmic type you know, after processing. It's just kind of giving you the raw sensor data. um you know, and the less algorithmic type of fixing that goes on, the more pure the signal, you know, that I'm going to be able to get is. So, you know, it's something to explore.
Nice. Okay. Real quick, Sean sent us one more. The rad runs in this state all day, quiet and bright. Oh, dude. He's tested up to 1 hour. I mean, look, dude, you can't, if you're a plasma physicist, you can't have anything better than something that runs for a long time to evaluate. That's amazing.
I mean, I'm pretty sure, and I mean, I can't speak for it definitely, but like if you just run RAV in its standard original configuration, the way that it was originally set up, you know, I'm pretty sure you could run that indefinitely. Like I've never seen any signs of it wanting to change or give up once it stabilizes.
No, because it cools down. That's the thing. It cools down once you put it in structure. When it's in spark gap, it's all hot. When it goes to a RAV, it cools down.
Yeah. I mean, I'm a big fan of saying, hey, I would love to see the RAV that runs for days, like we kind of discussed earlier, you know. Like I
Oh,
want to see the RAV that goes and goes and goes and goes and just isn't turned off. The thing is like if you've ever seen one of these things in person, they're scary as fuck. And the idea of having it just like run and then walking away from it just seems like it.
I'd do it. I have two glass pieces on order. They're about this long, okay, and they're about 4 inches round. And I'm gonna put it like a tube around this thing, at the top and bottom, and let it run in there to the other one and back. That's the double RAV.
Do it.
And then I'm gonna put a coil right there in between when they come out. So to go into the coil, and come back out like that, like a core. And I want to see if I can pull energy straight from it.
Oklahoma guy, a member of ours for 5 months. Love that.
Right on, brother.
That's good stuff, dude. Thank you. Yeah. I mean, yeah, there's a lot of stuff that we still need to do and try out. And I think that long-term testing is definitely something to do.
Well, dude, if it lasts that long, I mean, God, you imagine running that for several days, what you come up with?
I mean, realistically, I don't think it, you know, I don't see it getting any worse or deteriorating or failing once it stabilizes. I mean, that's the thing. Because the thing about the RAV is that what we were talking about earlier, just about like what you can see and what you can't. Well, there's a lot more with RAV that you can't see than you can, as far as what makes it actually work. You know, the flows, the exchanges, and all this other stuff. It's all going on behind the scenes. You know, and what you really see is just that result. And that to think what that field does if it were allowed to permeate, and grow in its
Well,
saturation and all that sort of stuff is kind of pretty cool because I don't think it's going to have any abnormal environmental effect, but it may affect the RAV, which then may affect the environment.
well, hold on. I think it will have an environmental effect, and I'll say why. Okay, because it sets a structure as soon as it exists. So as soon as it turns on, there's a structure around it. Whether you see it or not, it's right there. It's already set a zone which it's working in. Okay, but then it's playing with the gas because it's high voltage and it's ionizing. You're going to play with the gas around it. So the longer you leave it in that state, the more it's going to mess with that gas around it. Now, day after day after day, it should change that environmental condition, right? Because it's putting more resistance on the outside to it. So who knows where it could go, man? I'm just saying it may grow an extra satellite or two, and you may start seeing funny things happen.
Could well be, and I mean, if you propose, even if it, let's say that it amplifies over time, okay, based on its conditions, just growing up in the saturation. Let's say that but that growth is exponentially slow. It would only be exponentially slow at first, right? Because it needs to be able to kick off that process. But since it would potentially grow by orders of magnitude based on how it is just at any time previously, right? Once it gets to a certain size, those small differences start to make a big difference, right? So it may take a long time for any noticeable change to occur, but once that noticeable change occurs, that probably goes into a rate of acceleration.
Mm-hmm.
So that is quite possible, and provided material failure, which has never been a problem with RAV. You know, it's possible that the energy density levels could really become extreme. Um, it would just be funny if you left RAV alone to do this, and then like you're in your kitchen making like pancakes or something, and then like the RAV is just like floating over there, like, "Hey, dude, where did you go?" It's like, you son of a bitch. It's like, see, I couldn't have stayed in that field so long. Now it thinks I'm part of the environment. It wants to hang out by me.
It creates a gravity well in your garage and everything's sticking to it.
Right. Or it randomly comes and checks up on you and then goes back.
Dude, if it created a ball of light right there, dude, I'd strip down to my chonies and do a Raiden dance. Okay. Dude, I'm sorry. It's just funny. That'd be something unique.
Yep.
Oh man. Yeah, that Rav's awesome. Yeah, I do agree with Sean though. He said it would nuclearization, so it would basically just after an amount of time it explodes. So but that's just what the sun's gonna do anyway. Over a certain amount of time, man, it's gonna explode and expand out. I expect the same thing to happen to the Rav. It's gonna quit because it can no longer take the constraints of it, and it's gonna reach the point where it finally gives up the time dilation that's going on inside of it, and it just down back to the core.
Yeah, and just like a sun or a star, it would expand exponentially
Mm-hmm.
and throb before it.
Yeah.
Unfortunately, that collapse event is, you want to talk about the energetic release. I mean,
Oh yeah.
think about it, right? First, it starts to swell, and then it starts to throb, and then it literally goes. What's
Yeah.
that sound like? That sounds exactly like how creation occurs to me.
Yeah.
You know? I was warned about that in junior high school, and then again in high school, and then several other times throughout my life.
Oh man. Oklahoma guy, man. Thank you very much, dude. Five Old Man's Bills memberships, brother. Right on, my friend. Right on. There'll be a lot of new members in there, at least 10 from what I've seen so far. So I gave 5, you gave 5, man. We're good. That's so awesome, brother. Yeah, it's such a fun thing to think about the RAV. Is it? So in that time, just think of it this way. If it's creating a time dilation field on the inside, depending on how much it is in there, is it creating the conditions if you leave it over time to make planets and stuff out there? And then you have little beings yelling at us, you know what I mean, for making their solar system and then turning it off. You know what I mean? That's the craziest thing to think about.
It really is, man. I think everything that we're doing is finally beginning to come full circle. And I think that it's something worth not only worth saying, but I think that showing it just as important, doing it. And that way we can realize why that doesn't work and then refine it some more. But
Joe,
I think it's pretty close, man.
That's something you're going to like. So this time he puts it in a coil.
Well, that coil should, once the wrap forms in there, it should induce a current. So is the coil hooked to anything, Sean? It doesn't look like it is, right?
No. But it's definitely putting out plasma on both sides of it.
Yes, it is. That's because it has a current.
We can see the current light in the beginning of the video. Hold on. Right there. It's changing colors on the center. Already, just by having the field there that's creating a magnetism.
Yep. Funny how it works, isn't it?
Dude, you could see that environment whipping around there, Joe. That's the one you need to do the photo on.
Yeah.
Look at it move.
I'm definitely going to do the photo on that. I'll, make sure that I get the video and then I'll tear it apart. But you could see, yeah, I mean, what I wish to see out of like this is, and I know it takes playing and the configuration and everything, but, just having the RAV, centric of the coil, I think would be really good. Because it definitely bring a magnetic element to it. And that could lead to a secondary compression, induce secondary compression just based on having a coil around it, aside from it picking up the current.
I completely agree with you, by the way. I want to see that as well. He said the next one, he says is while. Okay, hold on. Well, that's the last one I got so far. Put that back up there.
Yeah, it takes a second. I know when you send on Messenger to go through. So if you just sent it, and give it a sec.
Yeah, wait for that thing to ding. Oh, it doesn't matter the diameter or type of wire used in the coil. So Sean uses a spring wire, stainless steel spring wire that we get on Amazon. And it's, I guess, for pianos or something like that. And it works awesome on the anode portion of it. And that's what he's using here. It's high heat tolerance is what's going on. It doesn't deform.
Yeah, Dennis saying aluminum wire next. Yeah, I mean, if you could do the copper, like just a regular copper wire that's aluminum coated copper, like copper plated, that's definitely the way to get the most current out of it. That's for sure.
Well, yeah, the way you build yours, Joe, is awesome too. You take the screw or a nail and you wrap it with the wire around it. Yeah, something different in itself. It holds up better.
Yeah. Yep.
I know.
That was a good little trick. You know,
I believe I saw Darren using that, man. Excuse
it
me,
works.
Dennis was using it.
It works twofold. You know, it works to fasten the wire to your anode, and at the same exact time creates a secondary flow vector of a magnetic component right off the bat. So I've always been a proponent of that idea. And frankly, the idea wasn't mine. It came from the piano wire. And if you remember, that's how Rav started, was with piano wire.
Yeah,
Um,
the wire wrapped around the wire.
and honestly, you know, like, I'm not saying that that the direction isn't right, but bringing piano wire back into the fold as an anode, to me, is a wise idea because it was so reliable. You know,
Hmm.
it really made the most stable Ravs, I think, out of the bunch, to be honest.
Yeah, no, I agree with you, Joe.
Mhm.
Yeah, I like the different configurations. Always nice to see something new.
Oh yeah.
Yeah, guitar string made that way. Yeah, that's true. Yeah, you have to go over there and clip it at the right distance and everything. It would probably work just fine. They're heavy duty, man, those wires.
Oh yeah. Yeah. I would use like a bass string, you know, is to get like nice fat windings around like a thin center core. And you know, you can go to town with that and give you your magnetic bias right out of the gate.
Hmm. You imagine instead of the coil being right there, if you put it off of it, okay, and then pulsed it, and then you know what I mean? You
Mhm.
probably see the plasma suck into the center and go in a straight beam.
Here's that anode right there.
Okay, hold on, hold on. Pull
Poke
it back
it,
just a little
poke
bit.
it.
Yeah, pull it back just a bit. Right there. Now we can see it.
Yeah, it's
It's a
still a little blurry, but you get the kind of get the point. The point, get it? Yeah, but that's all that is. It's funny. All it is a copper, ribbed copper nails, like steel wire wrapped around to fasten the wire to it. Is that shoved through like a big pen that I shrink wrap, you know, like, just to keep it like straight.
nice.
But yeah, this thing worked like a charm. You know, that's the whole thing. Looked like that.
Thing is huge.
Well, you know, that's so I could adjust it up and down. So, you know, it's like I have like a little arm thing, like chopsticks or whatever, then you hold it like that, you know, like, and then you could sit there and you could direct the angle, you could direct the distance, right? Yeah, just like two chopsticks with rubber bands on either side, you know, so it like holds it, and you can slide it up and down.
That's awesome.
Yeah, I'm an innovative poet, you know, like when you're poor, you got to figure shit out. You like open up the junk drawer and be like, all right, how am I going to do this?
Oh my god, dude, I do that so much, Joe. I can't even tell you. Like, I have a drawer full of different capacitors and all this other kind of stuff. I love opening that thing, man, throwing everything at this whatever I'm working on until I get it right.
Yeah. Okay. And Yanni brings up a good point. Galvanized wire, be careful with that because zinc is a funny thing when you start running current through it. That's not galvanized wire. Throwing it out there. That was actually silver plated steel. And it was meant for jewelry. So it was like, you know, it's like sterling plated steel wire. So it's not galvanized.
Nice. 12 gauge copper on the one that's going on right there. Yeah, if you know what? If that thing was hooked up to a ZVS, I'm going to tell you right now that ZVS would have trouble. Okay. You see the energy coming off it and pushing back? That right there is what's going on in your RAV experiment, Joe. Is that energy's building from the RAV and then pushing back to that coil.
It's all that back pressure. I'm well aware and I know. And once it goes back where it came from, it does the same route that increased its voltage in the first place. So, you know,
So,
it's just going back up another coil, increasing the voltage further.
but that's what that snubber circuit is. So it goes through the diode to go out, right? At the very bottom of the coil. So before it gets all of its high voltage, okay, it has a diode that goes this way. But then over top of it, it has one that goes the other way. So now this one only flows this way and into a capacitor bank. So as this one starts to resist and push back, instead of going through this one, which you can't, path of least resistance is over here. So you can feed this back into the coil, you know what I mean, and run it, and it'll boom spark it up.
Well, that's exactly what I need to do, but you know, I still don't like. We could say the words, but I don't know the parts. I mean, I'm sure I could figure it out. I mean,
I have to build one. I have to build one anyway. I should really get on it. I've been doing other stuff.
yeah,
I've been working on a Vidini device, man. The one right behind me, man. Trying to get that thing fixed up and running, and it's it runs. But it likes to burn some parts though, so that's what I was saying earlier. I'm gonna fix it. So
yeah. Well, I mean, for what it's worth, I mean, if I were to bring it over to a cat and stuff, I could probably dump it back into a battery bank because I have all these I have all these disposable vapes that I used to use, right? And these things are the biggest waste and terrible whatever. But you know, I tried to get them apart before, but they're a huge pain in the ass, and I was like, ah, whatever. But then like finally I just like kind of ripped one apart and I was like, wow, this is rather easy. So you get in there and there's a 3.7 volt lithium ion battery, you know.
you may set that sucker on fire pushing that much voltage into it.
Yeah, maybe.
Because you got to remember, it's going up the coil, but then when it's coming back, it may be coming back as high voltage. You know what I mean? When it's compression back, yeah.
I guess we'll see. Whether or not I use it for that purpose, I was just going to run them all in series and then stick around with them that way. That's what I was going to do. That was the idea. I was like, all right, 3.7. Yeah, 7. It's like this is a fast voltage multiplier once you start rigging these things together, huh?
Yeah. So funny.
I mean, but look at this. Look, that's it pretty much. You get that puppy off with a pair of pliers, you pull all this bullshit out, and then that's it. Then it's got here. We'll do this live. It takes like a minute, right? So that's the top off. This is probably the biggest pain in the ass part. Is like there's a sticker. Okay, you're under the sticker now. Cool. Rip that off. Nice. You take this out. Oh, that had some juice left in it. They lie. I want you to buy another one. All right, and pull that out. Cool. Pull this out. Nice. Punch this through. And now you're in. That's it. So the LED screen, and then behind it is all the bullshit, the stuff that you want. And then you could just like literally slide it out. And now you have your 3.7 volt lithium ion battery hooked up to the LED screen, which like still functions, right? So like you could click this thing, it lights up, cool. You know, and yeah, it's actually got a neat little pressure like you know, switch situation somewhere. Wherever it is. But you could actually leave that, and if you suck, if you're like up to the sensor, it'll fire. It's actually kind of funny. Yeah, it's like underneath one of these things. I don't know. I pulled the whole shit apart before, but no, it's under the battery right there. Yeah, so that's how that works. Yeah, when this come out, and then right in there where you're looking, see that little guy? Right? That thing is the pressure sensor. So if you actually take this little gasket guy off and you do something, what do I gotta do? I don't know. You do something. I don't have a straw or anything.
Ah, yeah,
But
well, you do something.
yeah, it does something. But here, okay, cool. Let's see.
Oh, there it goes.
Not what you want. But it definitely triggers the circuit though. So cool. Yeah.
I love it.
Yep. So yeah, but I don't know. I have a bunch of these kicking around, so I'm gonna have a whole bunch of those kicking around. I'm pretty sure, like, if you were to go buy this cell, like just the cell, I'm pretty sure these things are like $5 a piece.
Yeah, they're probably expensive.
Yeah. And I mean, for what it's worth, it's got a USB-C charging mechanism right there too for it.
Yeah.
So, like, I mean, realistically, all you got to do is, like, if you keep that linked up, you can charge it too.
Nice. Right on, yeah.
So,
All right, guys.
I wanted to know how to take these things apart. That's how you do
Now that we got all of our vape understanding.
it.
So great, man.
I
Guys,
use
what
these ones now. See, these ones are not disposable. So,
oh,
like,
okay.
yeah. So, like, this is the part that just comes off.
Nice.
Then I hacked that so you could even refill that too if you want to.
Very cool. All right, Joe. It's been about 3 hours. We're getting there, man. I'm gonna say goodnight for everybody. So I just want to say thank you to Ulysses out there, man. Awesome. Then I gave out 5 Old Man Bills memberships. Dan, wish you well, man. And a safe recovery, brother, for all you've been through, man. You gave 2 stickers tonight, a 5 and a 2. Thank you very much, man. Shout out Sean, dude. He not only gives us totally awesome experiments to show on the channel, but he hooks us up as well. Sean, you're totally awesome, brother. Appreciate you, man.
And thank you to everybody for donating and everything. And hopefully this episode, I got to be honest, episode in review. If you're here for this one, you could skip a lot of the other ones. Like, I mean, I watched the numbers and stuff, but this really gave you the culmination of all the work.
Yeah, I want to say thank you, Oklahoma Man, for 5 Old Man Build memberships as well. Just real quick.
And thank you for being a member for 5 months as well.
Yes. So, yeah, I'm sorry, Joe. I cut you off. Yeah, you're absolutely right. Okay, absolutely right. We're getting it up to speed, man. We're getting everything worked out, and it's kind of falling in line with everything that we're doing. Hopefully, it shows some great results here coming up.
I hope so.
And then, oh, dude, light episode. Like, I know I sent Joe a rough draft today, a couple days ago, and then he's going to send me his, then I'll go back and fix mine. You know what I mean? But there's a lot in there, man. There's a lot of pictures to pull from, a lot of different sorts of things. I was hoping to trigger Joe's mind with as many different ones as I could put in there, and then he puts a bunch in there too. So yeah, that's totally awesome.
Yeah, no, that's going to be great stuff. And I just want to put out there for the people that really love the grab a flyer stuff and whatnot, and gravitate toward that, as what they want to see here and everything. It's been a little bit of a long, drawn out story. Okay,
Yeah.
But now, hopefully, you kind of see how it's all connected. The reason that these tangents are necessary, and frankly, we've all found that the tangents are sort of the key to all the stuff we've been looking for. So it expands beyond just that, but it's a part of it. And we knew it was a part of it, but it wasn't exactly clear how. But I think that today's episode really made it connected those dots as to how that is the binding factor. It is the key to connecting the inner fields and what that's doing and the outer fields, running it all through the system, and then just creating this one thing that works all independently, doing all the different electromagnetic vectors, but then brings it all together in harmony. And that is it. That's what the missing component of the idea has been, is how does it all communicate together? And that's been the key all along. That's the bridge of the gap. So,
Yeah.
I
High
hope
voltage
that's what you
coupling.
guys got out of it.
Right on, man. Yeah, he's got it right, man. Aaron's got it right. High voltage coupling, man. Well on, guys.
Yeah.
All right.
A decoupling.
All right, guys. Thank you very much. Have yourself a great night, man. And we'll see you guys on Monday.
Right on.
And hold on. Real quick, I'll see you guys later on Traveling Fools channel as well. Okay. And then shout out Mike Faraday over in his channel, man. So, anyway.
All right. Have a good weekend. Peace and love.
Later.
The old man Bill. The old man Bill. The old man Bill. The old man Bill. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality restricted from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.